Now I'm going to do the classification. Can I change the slide? Dona, is my video lagging? Dona? Can I change the slide?
Yes, so your audio is lagging a bit.
Okay, just let me switch off my camera.
Okay.
Can you let me know? Am I audible clearly?
Yes, sir, now you are.
Okay. So the classification is also, this is your primary, this is your secondary, and this is your tertiary. This is the classification we just did. Now come to the nomenclature part, which is very, very easy. I'm going to explain this to you and then we'll give you some questions. As you can see, this nomenclature, its name is basically alkane plus amine. That will give you alkanamine. Alkane amine. So if you have this, what is the name? So you can see only one carbon containing group is there and one carbon is there. That means methane amine. Can you name this? Just let me know the name.
Ethanamine?
Now what you just said, ethanamine, right?
Yeah, yeah.
Its name is ethanamine. And these both are 1 degree or primary amine, right? So the
Yes,
primary amine,
because it's attached to one
yeah,
carbon.
one carbon. Now, if I'm going to give you this, you can see there is two branch of carbon. There is two option. One is you can see here, and another is here. So you have to take one of them as main parent chain, and since both alkyl group has same carbon, same number of carbon, so you can take any one of them as substituent and any one of them as any one of them as parent chain. So I'm going to take this as a substituent. So one carbon as a substituent, name is methyl, and this is your main parent group, main function, main parent chain, methyl methane amine. Are you getting my point?
Yes, sir.
So it's very easy, or we can write N-methylamine. This will be much better. Instead of writing the number, we write N-methylamine. That means this methyl is connected directly to this N. So if I'm going to give you this, can you name it? So let me explain this. This carbon is containing only one carbon. This side carbon is 3,
Two carbon.
and this side carbon is 1. So this will be the branch, right? And this
Yes.
will be the parent. So what
So
the
the
name
chain
will
which has
be
the more number
N,
of parent will be, I mean, more number of carbon will be the parent.
parent chain,
Okay.
right? So this has only one carbon, so this is your branch. So its name will be N-methyl, and this is the parent chain which contains 3 carbon, propane amine, right?
Yes, sir.
Now, if I'm going to give you this, can you name it?
So is the first one N ethyl butanamine?
1, 2, 3, 4. Yeah, it is. Can you go for the next one?
So can you show how to name this one?
Simple. The concept is same. How many carbon this contains? 3 carbons. And how many carbon this contains? 6 carbon. Can you tell me which one will be the parent? This one. This one will be the parent.
Yes.
And this is your substituent. You can call it or branch. So if it is branch, its name will be N-propyl. Yes or no? Since 3 carbon.
Yes.
And what does this? This is your benzene. So it will be benzene amine.
Okay.
Is that clear?
Yes, sir.
Now, if you have this, we are done with the secondary also. Now, if you have this, so this is your tertiary. Now you can see this contains 1 carbon, this also contains 1 carbon, this contains 3 carbon. So you have to decide which one will be the parent. One will be the parent chain, and another two will be the another two will be the substituent. So its name will be N, N dimethyl, and it is propane amine. Is that clear?
Yes, sir. So why N comma N?
Because this both substituent for substituents, instead of numbering, we used N, right? That means it is connected to N, and both the substituent here connected with N. So instead of writing N methyl in the we write N comma N dimethyl. In the previous one, you can see N propyl, N methyl. Do you remember? Have you got it?
Yes, sir.
So I was giving you a question. This question. Please do write it, then I'll give you another question.
So is the first one N comma N methyl ethyl?
No. See, follow the basic rules. I used both together, N comma N dimethyl. If you have different substituent, you have to write twice. Like you have to write N ethyl first, because it comes first in alphabet order, and then N methyl. Are you getting my point? And
Yes,
then
sir.
propanamine. You cannot use together if the substituent are different, right?
Okay. Yeah.
The last one, please.
Is it N comma N diethyl butamine?
Butanamine. You told us,
Butanamine. My bad.
yeah, butanamine. 1, 2, 3, 4. So on not only buta just represent number of carbon. N that represents the bond between carbon
Single
is
bond.
single.
Yes.
Okay. N
So will
comma
there be
N
a
di.
question with double bond?
So we will deal with that. We have to write the uh, position of the double bond as well.
Okay.
Okay. So basically, we write the nature of the bond at the end in parent chain, right?
Yes, sir.
So at that time, you have to use if there will be a double bond, like let's say this is your situation. Okay. The this part will be same. This part will be same. Let's say here is the double N comma N diethyl. Now you need to numbering 1, 2, 3, 4. So its name will be but. 2 in 1 amine, or you can use but. The rest part will be same. 2 in amine. In amine. Are you getting my point?
Both vegan, right?
Yeah.
Okay.
Can I change this slide?
So and if there is one more double bond, then we write 2 comma the other number and then we write
Something
the rest.
diene.
Diene. Okay.
Okay. Is that clear?
Yes, sir. Yes, sir.
Can I change the slide? Okay. Now I'm going to give you some questions regarding this, in which I think every types of question will come. The first I'm going to give you is CH3CH and H2. Just write.
So for the first one,
Yeah.
it's only connected to one CH. So how do we take the parent?
Okay. This is a primary, secondary, tertiary. What do you think?
This is primary.
Primary. Now you need to number it. Numbering. You cannot numbering from here because you are jumping in between the carbon. So you just need to number it from 1, 2, 3. Yes or no?
Yes, sir.
Now the name will be, there is no substituent. Can you see any substituent here? There is no substituent in primary, right? So its name will be parents and propane. 2 amine that represents in propane, the amine functional group is connected to the second carbon.
Okay.
Is that clear?
Yes, sir.
Okay, please do it.
Is the second one N comma methyl 1, 2, 3
Can you repeat it
propane?
again?
Hmm?
What you just said?
N comma methyl.
N-methyl.
I mean N methyl, N hyphen methyl.
Yeah, yeah.
And then
Propanamine.
1, 2, 3 propane amine. Yeah. Which is the third one?
Are you able to solve it? Yes or no? This is your C2H5. 2 carbon, 2 carbon, 3 carbon. That means this is your parent chain. Yes or no?
Yes. So it'll be
So
1,
this
2,
is your
3.
substituent containing 2 carbon. So its name will be,
N comma
both are
N.
same. So we are going to write it together. N comma N diethyl
Yes.
propanamine.
Then
Isn't it
propanamine.
easy?
No, I asked. The third question wasn't there.
Oh, third question. Oh, sorry. I forgot to write the number. The numbering is wrong.
No,
No.
it's okay.
Now just give it a little try. Don't ask and let me know the name directly. If it will be wrong,
Okay.
I will correct it.
So the fifth one, is it propan 1 en amine? En amine, I mean.
From where you did the numbering? Here, left or right?
The left to right.
Left to right, that means you did this numbering. 1, 2,
Yes.
3. This is
Yes.
your parent chain, right?
Mm-hmm.
This is your parent chain. Oh, wait a minute. This is your parent chain, right?
Yes.
Now, if you are going to name it, there is no branch, so directly jump to the parent chain.
Yes.
And its name will be prop 2 in 1 amine. Don't write E at the end when you are going to write the name. 2 in 1 amine. Isn't it easy? Or you can directly write in amine.
Yeah, that's what I said. I said prop 2 en amine.
Yeah, yeah,
Oh,
very
okay. Thank you.
good.
Is the sixth one methidiamine?
Meth, where is meth? No, just try this and this.
Oh, okay. So is it 1,6 diamine?
First, write the
Dihexamine?
name of the number of parent chain instead of writing amine directly. Are you getting my
Hex.
point?
Yes.
Hex. Oh, wait a minute. Yeah, this is the question, right? So you need to write hex, and since all are singly bonded, see, you need to write it in expanded form to understand the concept. 4, then comes 5, and then comes 6, and here it will be NH2, and here it will be NH2. Now, if you are going to write 1, 2, 3, 4, 5, 6, so hex and all are singly bonded, so hexane 1 comma 6 diamine.
Okay.
Isn't it easy?
Yes, sir. Seventh one, can we just directly write benzamine?
Yeah, benzene amine, not benza.
Benzene amine? Okay.
Oh, what I want to say is that you told me to write, can we write benjamine? This is
Yes.
wrong. You need to write directly the name benzene
Mm-hmm.
plus amine, in which you need to remove this E in benzene. So it becomes benzene amine. This is what I told.
Okay.
Got it?
Yes, sir.
Now, its common name is aniline, which is very, very famous for, its name is very famous. That's why nowadays this is treated as IUPAC. Okay, so either you can write aniline or benzenamine.
So either we write, we'll get marks in both.
Yeah,
Okay.
like what is the name of this IUPAC name?
Phenol.
Do you know what is the name of this compound?
Phenol.
Phenol. Is it IUPAC or common?
It is
Okay.
IUPC.
Actually, initially it was a common name, but now it is treated as IUPAC. Okay.
Okay.
Its name was basically benzene plus all, that means benzenol. Okay.
Mm-hmm.
But this phenol is now treated as IUPAC as well. So either you can write aniline or benzenamine, both are correct. Okay.
Yes, sir.
Okay. So you know how to write the structural isomers, right? In class this class 12. Uh, you know how to write the structural isomers? Yes or no?
Structural isomers, could you show an example?
Okay. If this is your pentane, and if you want to write the structural isomers, that means isomers that represent same chemical formula, different structural formula, same chemical formula, different structural formula. This is what a structural isomerism is. Is that clear? Now you can see
Yes,
it
sir.
has a formula C5H12. So I'm going to write it like this. This also having the same formula. I'm going to write it this. This also have the same formula, but you can see the structural formula is different, right?
Yes, sir.
Okay. Now I'm going to start preparation. MOP, that stand for methods of preparation. MOP, methods of preparation of amines. Okay. So the first is basically reduction of nitro compounds. Reduction of nitro compounds. You can easily reduce this and you will get amine. So there are two methods to reduce a nitro compound. This is your nitrobenzene. And if you are going to use H2 in the presence of ethanol and catalyst PD, palladium, then this will be reduced. What is reduction means? Reduction means removal of oxygen or addition of hydrogen. So you just need to remove the oxygen and add hydrogen. This is how you will get done. Okay. There is another method for this. There is another way. Instead of using H2 in the presence of palladium, we can use tin in the presence of HCl and iron, or iron in the presence of HCl. This is your NO2. Or either you can use tin in the presence of HCl, or either you can use Fe in the presence of HCl. So you will be getting this. And the most preferred ways to do prepare is this. Please do write. Let me know if you are done with this.
Done, sir.
Very good. Now the next preparation is ammonolysis of alkyl halide. The second is ammonolysis of alkyl halide. Now, what is ammonolysis of alkyl halide? So you are going to do ammonolysis. That means you are going to react ammonia with alkyl halide. So this is your ammonia, which is nucleophile. You know what is nucleophile? Electron-rich species. And if you are going to react this with alkyl halide, see what will happen. Since this Rx, I just wrote it wrong. This is your X, which is more electronegative element. So it will withdraw or take electron from R and it comes out to be X negative. And now there will be positive sign. So this will attack on this and it will form NH3 R positive. NH3, or you can write RNH3 positive like this. And you can see there will be a ionic bond between this RNH3 positive and X negative. And this is known as basically substituted ammonium salt. Are you getting my point how you get it, or should I explain it more?
Understood, sir.
Okay. Now see what is ammonolysis of this alkyl halide. If you have 1 degree amine, you are going to react this with Rx. Now see what you need to do. Just remove one hydrogen and replace, you can see, remove one hydrogen and replace this with this. What I want to say is that this will be, can I write this as this? So this will take its electron, it will have negative charge, and this will be in negative and this will be in positive. So this positive will attack on this negative. And since hydrogen's electron gained by nitrogen, so it will have positive and they both combine to form HX. They both combine to form HX. Now what we will get? We will get R2NH. This is your primary 1 degree and this is your secondary. Are you getting my point? What you need to do, just replace one hydrogen with R. Again, you need to do the same. Replaced one hydrogen, that means with R. R2 is already there. One of the R will go with nitrogen. It becomes R3N and HX will be the byproduct. Again, you need to do the same Rx. And now you know that this nitrogen has lone pair and when it will go, it will have positive, this will have negative. So it will attack on this and it becomes R4N positive and X negative. This is your tertiary and this is your quaternary ammonium salt. Is that clear?
Yes, sir.
So please do write it. Are you writing it or not?
Yes, sir.
So, Dona, can you make a list of chapter which I need to cover for you?
Sir?
After, yeah.
So could you repeat that?
Yeah, can you make a list of chapter in which you have doubts so that I can plan our syllabus accordingly.
So I had sent this thing, those two chapters, only those two chapters.
Wait a minute. Oh, there are two more chapters, amines and biomolecules, right?
Yes, sir.
Okay. I'm gonna send you the notes of biomolecules. Okay. Let me know when you're done with this.
Yes, almost done.
Oh,
Done, sir.
very good. So this is your uh, preparation. Now I'm going to show you. In the first place, when you prepared RNH3 positive and X minus, if you are going to react this with a base, a strong base, you will be getting a primary amine. And with this method, only primary amine is the effective or major product, because with each step, the product decreases. So this will be the major product. Major product. Is that clear?
Yes, sir.
Now I'm going to give you a question, which is very important. Uh, right. Chemical equation. Chemical equations for the following reactions. First one is reaction of ethanolic NH3 with C2H5C. This is the first part. Please do. Let me know if you are unable to solve.
So I'm not sure how to write this.
Okay, no problem. It's very easy. What you need to do, reaction of ethanolic NH3 with C2H5Cl. Now, you have C2H5Cl and you are going to react this with NH3. What will happen? What will happen? It's very simple. One of the hydrogen will be replaced by chlorine. So what you will get? C2H5NH2. You will get this primary amine. Yes or no? 1 degree amine. And you can see the chlorine and one of the hydrogen will be the byproduct that we don't need to write. Yes or no? Dona. Dona, am I audible? You are not audible.
So am I audible now?
Yeah.
Oh.
Have you got it?
Yes, sir.
Now, again, you have to react this with C2H5Cl. C2H5Cl. Again, this chlorine will take one of the hydrogen and this part. Basically, you can see this C2H5 will be replacing the hydrogen. Now you will be getting C2H5N and C2H5, and then one hydrogen left there, and the byproduct HCl. This is your 2 degree. Now again you have to react this with C2H5Cl. Again, this will be replacing this hydrogen. Now you will be getting C2H5N, C2H5N, sorry, C2H5. This is your tertiary, yes or no, 3 degree, and HCl will be eliminated. Is that clear? Now you have to do again with C2H5Cl. What will happen here? This chlorine will take electron. There will be negative, there will be positive charge. And this nitrogen has a lone pair that will attack on this part. So what you will be getting? C2H5. Thrice is already there, and one of the C2H5 will come to make it 4 times, and then there will be N positive, and then this Cl negative, which is known as quaternary ammonium salt. Quaternary ammonium salt. If you are going to do the ammonolysis, you need to do up to this point. Is that clear?
Yes, sir.
If moles of this is given, like you need to use only 1 mole or 2 mole, so 1 mole is used here and another mole is used here, so you have the main product will be this. Is that clear? If it is given that only you need to use this much, then you need to stop according to that. If it is not given, then you have to do it to the end. Please do write it and then let me know.
So what is the word before ammonia?
Quaternary ammonium salt.
Done, sir.
Done. Very. Now the next part of this reaction is very easy. You need to do the ammonolysis of benzyl chloride. First, let me know the formula of this benzyl chloride. And reaction of amine so form with 2 moles of CH3Cl.
So done, sir.
Okay. So have we done it like this? What is the formula of benzyl chloride?
C6H5-CH2-Cl.
Yeah.
On
With
treatment
NH3,
with
what you need to do?
NH3.
This chlorine will be replaced by NH2 and hydrogen will be gone with
Yes.
chlorine. So this is what you
C6H5CH2.
will get, right?
Yes.
So it is
Benzyl.
also has been said that 2 moles of CH3Cl is you need to use CH3Cl,
So
2
2
moles.
CH3Cl.
That means basically one hydrogen will be replaced by CH3Cl, another hydrogen will be
Yes.
replaced by CH3Cl. So
CH3Cl.
this is what you will get, and here it will be CH3 and here
CH3
it will
and
be
bottom
CH2.
CH3.
Now,
So we
if you
can
are
put
going
it
to
on
name
the
it
top.
top, yeah, you can put it anywhere.
Okay.
N comma N dimethyl
Benzyl.
phenyl benzenamine. No, methenamine. Phenyl, we used phenyl here. Methyl amine. So you can see this is your 1, 2, and this I took as a parent chain. This